Okay, I want to start with the one at the bottom so I can erase it and make room for doing these and some others. Maybe I don't need to, I don't know. So the first thing we want to do is distribute the 5 into here. Okay, I'm assuming you guys can get 15x squared minus 35xy plus 20x if you 5 times this. Remember, when you write 5 right next to the parenthesis there, it's implied to be multiplication. So when we say distributive property, we mean actually multiply. Now here, this is a little tricky. People have different ways of attacking this. This confuses people. We're distributing a minus 2x. So minus 2x times x is a minus 2x squared. But a minus 2x times a minus 2xy is a plus 4x squared y. Because the minus times the minus is a plus, and x times x is x squared. And then a minus 2x times a plus 3 is a minus 6x. Okay, so that's the first thing. Always get rid of parentheses. Parentheses stop you from continuing problems. So now we look for like terms. So 15x squared, take away 2x squared, leaves 13x squared. Okay. Are there any other like terms? What? There's 20x here, and this negative 6x. Remember, like terms are being defined as exactly the same variables, exactly the same. So x and x, but when we put together like terms, we always add or subtract their coefficients. So positive 20, take away 6 is positive 14. X. Okay. Now, this is an xy, but this is an x squared y. They are not the same. They are not like terms because that one little difference in the exponent changes everything. So we just throw these down, 3x, oops, 35, come on, dummy, 35xy and plus 4x squared y. And now I think you can read that. So that's the answer. Now, somebody is invariably going to ask, does it have to be in this order? The answer is no, it doesn't. You could put it in any order you want. I'll talk later about when it has to be in a special order. But when you have a whole bunches of different variables, x's and y's and z's and pluses and minuses, then technically it doesn't have to be in any order at all. Now, some instructor may make up their own rules. Well, then you just got to go with it. But when they have multiple variables, then you can throw them down in any order you want, and you are technically correct. So that was number 3. I might have to erase that when I'm talking about number 1 and number 2 for a second. Any questions on number 3? Okay, now I'm going to try and mislead you. I'm going to try and trick you. Okay, our rules of exponents, the first rule of exponents that we were talking about all last week, said to distribute the power in. First, distribute the power. Okay, so this should have been 2 to the second power times x to the second power times y to the second power. Then our rule said look for a power to a power and look for same base. There are none of those, so this is just 4x squared y squared. And that is the correct answer for this. Okay, but then we come back to number 1. If you did this, 2 squared x squared plus y squared, and tried to tell me that it was 4x squared plus y squared, you got it completely wrong. 100% wrong. But you're going to say, but the rules that you talked about last week said distribute the power. Yeah, but the rules I said also only applied when everything inside was multiplication or division. Okay, that's the subtlety I want to talk about for a couple seconds. All of those rules of exponents that we talked about last night, Jesus, where was I? Okay, last week. Okay, were when the terms or the things inside the parenthesis were all either multiplying or dividing together. When they were, then you can use this distribute the exponent bit. But over here, it's really important that you see this. This is a plus. Those rules of exponents fail, completely fail, if there's a plus or a minus inside the quantity. Okay, and that's something you guys have to pick up on, which is why I was given this problem tonight. When there's a plus or minus inside the quantity, then all that crud we talked about last week, or most of it, out the window. So the question is, what do you do? Well, you go back and you say, squaring means multiplying by itself. So when you see 2x plus y quantity squared, you write it down twice. Some instructors have a formula they want you to remember if it's a quantity, a binomial square. Binomial means two things squared. There is a shortcut pattern. And I'm just going, oh my God, you got enough stuff to memorize. Why memorize that? What you have to do is write it down. And then we talked about last week different ways of multiplying polynomials together. Okay. Some of you like to put it in the matrix box. As I was walking around, I was watching you guys last week do that. Others have been taught to very slowly and very carefully distribute like that. It doesn't matter to me how you multiply these together, but you do have to multiply them in, as polynomials. So this is a 4x squared. This is a 2xy. This is 2xy again, and this is a y squared. Okay. Any questions how I got my numbers inside that box? What I multiplied together in order to get all these extra junk inside the box? Okay. Then we always look for like terms, and if you use the box method, like terms will almost always be on a diagonal like that. So your final answer is 4x squared. This is a 4xy. Whoops, come on, xy. Remember, when you add like terms, you add the coefficients, keep the term, the xy. When you add or subtract like terms, you add or subtract the coefficient, and you just keep whatever the variable was, plus y squared. That is the only answer for problem number 1. Now, unfortunately, I erased problem number 2, or 3 rather. Are there any questions about anything up here that I've talked about or shown or done or anything? Okay. So I'm trying to kind of get you ready for the chapter 5 quiz, 5 and 6 quiz. This is chapter 6 stuff. Okay, that will be coming this Thursday. So I'm hoping you guys have started some of the homework and have some, and this makes sense. All right, let me erase this then. I don't hear anybody yelling at me.
Hey, Professor, is the
Right.
quiz, is it going to be in class or on mom?
Yes. That's me being a smartass. The quiz will be, you'll have 5 questions in class. Turn in that work to me and then go home, and then you'll have a couple days over the weekend to do it on mom. That was what I was going to put up here. So the big quiz this Thursday is about 5 questions in class. Okay, and then the rest are on mom, but you'll have like 2 to 3 days. Does that make sense? And that's why my answer was yes. It will be in class and on mom. Okay. Is that okay with everybody? My participant list says I've got almost everybody here, so that's what's going to happen Thursday. You're going to have in class, we're going to review, we're going to do more of chapter 7. We're going to start chapter 7 tonight. We do a whole lot of 6 and 7 in review. Then right at the end of class, I'll hand you a little 5-question quizzy. You take it, turn it in, go home, and look for mom. Okay. If you want to do it that night, great. If you want to do it the next day, fine. But you can't forget. All right. So let's try the rest of these. Okay. We have number 1, 2x squared y to the 4th quantity cubed times -5 x y to the 3rd quantity squared. Number 2, we have 24 x to the 5th, y to the 3rd, z to the 4th, over -27 x to the 7, y to the 7, z. And the third one, -6 x to the -3, y to the -5, z to the 2nd, over 9 x to the -7, y to the 2, z to the 3. Okay, that could possibly take you another time. By the way, well, these are another preparation for Thursday. Okay, since these are all multiplication, those rules of exponents that I was talking about apply. There's no pluses in between all these things. So our first rule was distribute. So this is 2 to the 3rd times x to the 2nd to the 3rd times y to the 4th to the 3rd times this mess. Okay, look how I wrote this. -5 squared. You're squaring all of -5. If you do this on your calculator, if you do -5 squared versus -5 squared, you'll get totally different answers on your calculator. You need to be careful about that. You're squaring the entire number there, all of -5, which is why I use a parenthesis, just to be safe. This is times x squared times y to the 3rd squared. Okay. So the next step is, number 1, we're going to do arithmetic. 2 to the 3rd is 8. -5 to the 2nd power is 25. So we'll do that. But the next step in that list I gave you after you distribute the power was to look for a power raised to a power. And when you do, you keep the base x, multiply the powers 2 times 3 is 6. Y to the 12. This is times 25, x to the second, y to the sixth. Okay. So now all we did was kind of get same bases together. I'm going to jump to the answer. 400. 8 times 25 is 400. X times x is x to the 6 plus 2, which is 400 x to the 8. When you multiplying with the same base, you keep the base, whatever it was, add the powers. Y to the 12 plus 6, which is y to the 18. And that's your final answer for problem number 1.
It's not 200.
Oh, it is 200. Thank you. That's what I get for doing it in my head. Thank you.
It's okay.
No, it's not. Usually I shouldn't be that much of an airhead, but I was. Okay, thank you though. That's the kind of thing I need people doing. Speaking up, yelling out at me, questioning me. So I like that. Is that all right with everybody?
Yep.
Okay, cool. Moving on to this one. There are 2 ways to do this problem that we've talked about. One way is what I call the cancel way. That's the fastest, easiest way. So, oops, what we do is just reduce number with number. 3 goes into 24 8 times, 3 goes into 27 -9 times. Then we move to our x's and we think, oh, look, I have 5 x's on top, 7 x's on bottom. After they cancel, I'll have 2 x's on bottom. Okay, move to the y's. I have 3 y's on top, 7 y's on bottom. So after everybody cancels, I'll have y to the 4th on bottom. And lastly, my z's, I have 4 z's on top, 1 on bottom. That will leave me z to the 3rd on top. There's an alternate way this could have been done following the official rules, but this is much faster. But I'll show you the official rules if you wish me to. It involves subtracting. 5, take away 7, subtract the powers. 3, take away 7. 4, take away the invisible 1. But as long as you get this answer, I don't really care. Is that okay for number 2? Everybody got that? So you're going to do great this Thursday. Okay. I need to erase my answer for number 1 because number 3 takes a lot of steps. Or not a lot, but takes more steps than I have room. So any questions on number 1 before I kind of erase my answer at least? All right. Okay, so again, there is more than one way that this problem can be done. And that's the problem. Again, you're going to hear me say it quite a bit as we get more and more sophisticated, as our math skills and understanding grow. There's more than one way to do a problem. There's only one answer, but there's more than one way to get to that answer. Personally, I and many other instructors prefer to get rid of all negative powers at the very beginning. And to get rid of negative powers, you just flip. Negative powers flip. If they're in the top, they flip down. If they're in the bottom, they flip up. So an initial step would look something like this. -6 over, not well, I can reduce that to 2 over 3. That's just plain old fraction. 6 over 9 reduced to 2 over 3. Notice we don't flip negative numbers. 6 and 9, those are just regular old dumb numbers. Okay, we don't have to flip them. Okay, we just reduce them. However, x to the negative 3 flips down to become x to the positive 3, where x to the negative 7 flips up to become x to the positive 7. That's the rule of negative powers. Negative powers mean the reciprocal, which is a fancy way of saying just flip it. Okay, on my y's, this is a little bit tricky. On my y's, the y to the 5th flips down, but the y to the 2nd does not flip. It doesn't have a negative power. So it just stays down there. Okay. And my z's, nothing happens with them. So z to the 2nd, z to the 3rd, just stay. Am I in the glare? Can you guys read my y's? It's kind of in the glare. Are you guys okay with that or not?
That's fine.
Okay. So now, after having flipped everybody, this is just another form of this. You just got to reduce x's with x's, y's with y's, and that kind of crud. So we end up with negative 2 over 3. Okay. My x's, I see 7 on top, 3 on bottom. So by the time they cancel, I have x to the 4th on top. Now my y's don't cancel. They just get bigger in the denominator. So I have 7 y's altogether in the denominator. Y to the 7. And my z's do some canceling, leaving me z, a single z on bottom. And that would be my final answer. Is that okay with everybody? Okay. Then I'd like to go on to the last topic in chapter 6. It's pretty simple, and maybe one question on the quiz, maybe one question on exam 1, if that, on this next topic. But questions on what I've done so far, either the 3 that I had up here first or these 3. Okay. Okay, I want to talk about the exam, but later in the evening, exam number 1. I would like to erase the stuff about the quiz. Does everybody understand this Thursday's quiz will be in 2 parts? Part 1 will be in the classroom. Part 2 will be on mom, but you'll have 2 to 3 days to take it.
This quiz this Thursday or next Thursday?
Next Thursday is a big giant exam. This Thursday is the quiz.
Okay.
Okay?
How complicated is the 5-question quiz?
Is what?
How complicated is the 5-question quiz on Thursday?
What do you mean, how come? That depends. I mean, it's just like I took them from mom and I took them from my lecture notes. So I mean, that's all it is.
Okay.
Most mom questions are right out of your homework. So I'm not sure how to answer that. It's right out of mom.
Okay.
Okay.
That's good.
Okay. In the tail end, and I forgot to, I think it's chapter 6.7. I think. Forgot to write down what chapter it is, so put a question mark there. Okay. It's called scientific notation. And there's a big historical reason why it was invented. Well, I'll tell you why it was invented. Because when Gutenberg invented his printing press, Have you ever guys seen like you go to Knott's Berry Farm or you go someplace and you see an old-fashioned newspaper, and what they have to do to write this number out, they have to put down a piece of lead with the backwards 2 on it, somehow imprinted, I don't know how. And then when you, that's a 2, believe it or not, and a backwards, and they put these down individually, and a backwards 0 was still a 0. But when they make this up on a printing press, okay, they have to set individual little metal blocks of these numbers, okay, that are all backwards. And then they ink it, they roll an ink over it, and then they put a piece of paper on it, and the ink transfers to the paper. Okay, and that's how they print this. That's how they have to print all newspapers for the longest time, is put down individual little blocks for each digit or each letter if they wanted to spell a word. But the blocks were always reversed, because when you ink it and then rub the paper on it, it reverses back so people can read it. Well, what happened when they tried to do this is not everybody had 1, 2, 3, 4, 5, 6, 7, 8, 9 different zeros. You know, you go to a little town out in the middle of the wild, wild west, and they're trying to print something up about a new scientific discovery. I don't know what it was. And the person's doing this, and he goes, I don't have 9 zeros in my little tray to put down there. Okay, I can't do that. I don't have 9 zeros. Okay, so they began to think, yay, how important are zeros anyway? Are they really important? So one town might write that number, print it out. Another town didn't have enough zeros, so they only printed out that number. And then people were getting, fake news, really, all because the printers didn't have enough extra zeros to print the number. So what happened? Well, scientists came up with the idea of, what if we convert this to a number somewhere between 1 and 9.999 times, and we do this time put a little x there for timesing, times 10 raised to some power. So for example, this number would be 2.7 times 10. Now, what happens is you need to count, okay, the decimal point was supposed to be back here. Remember, it's implied to be at the right end of a number. So you moved it back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10 to the 10 power. Okay, much easier for the printers to write this than this. Okay, you didn't need nearly as many little zeros and stuff like that. It's more condensed. That's called scientific notation. Up here, this is known as standard notation. This is what we normally see. And for nice normal numbers, this is just great. But for big, humongous numbers, we move to scientific notation. Okay, and that's all it is. It's taking a big old fat number, condensing it so it's a number between 1 and 9.9999999. Somewhere 1 in that, times 10 to some power. That's all scientific notation is. So if you guys have done some of your mom homework, it'll be like 34000, okay? And we want to convert that to scientific notation. Well, the first thing you do is you look at that and you think of it as 3.14. You make it you make it, you just simply force it to be between 1 and 9.999, whatever that is. Okay. And now you go back and you count. All right, well, how many places, if I move the decimal point to 3.14, it used to be here, 1, 2, 3, 4, 5. So we would say times 10 to the 5 power. And that's it. That's converting from a standard notation number to a scientific notation number. Okay, well, what if you want to go backwards? Well, that's easy. What if we had 5.02 times 10 to the 4th power? Well, all you're saying here is I'm going to move my decimal point 4 places to make it bigger. 4 places that way. So we're going to go, okay, 1, 2, and then you're going to have to go 3, 4. So this is 50200 with an implied decimal point there. So 5.02 times 10 to the 4th becomes 50,200. Okay. And again, a positive power here means you move the decimal point to make the number bigger. And that brings up the next issue. What about little tiny numbers? See, scientific notation was invented to deal with really big numbers or really tiny numbers. Example. Zero point zero 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 713. I have no idea what that is. Somebody's measuring something on a quantum scale or less than that. Actually, if it's quantum scale, it has more zeros in there. But they're measuring something that's incredibly tiny. Well, in scientific notation, we have to move this as a number between 1 and 9.999. So the first thing we do is take this and rewrite it as 7.13. We take what's called the significant digits, okay, and write them between 1 and 9.99, whatever that is. And then you ask yourself, okay, well, how many places did I move the decimal point? Okay, 1, 2, 3, 4, 5. So now watch carefully. We say times 10 to the 5. That's wrong. Times 10, come on, dummy, to the negative 5. I'm trying to make a big deal and I screw it up. Okay, why is it negative? Well, some people just memorize. When I move the decimal point to the right, I use negative. When I move the decimal point to the left, I use positive powers. I think of it a little bit differently. I think of it as, maybe it's just a guy thing. I'm compensating. I don't know, whatever. This is a little tiny number. Okay, 0.0000713. Man, that's a tiny number. Okay, but when I write 7.13, I've made it big, relatively speaking. So I compensate with a negative power. I had a tiny number. I made it big initially, but I compensate with a negative power. So it kind of balances out. Okay, make it big, but the negative power really makes it small, which is what originally. Okay, think about this. Go back to 270. I don't know. I'll just make up a different one. Yeah, that's a pretty big number. Okay, so you write it as 2.7 times 10 to something. And what you've done is you've made a big number small. 2.7 is small compared to this original number. So I compensate by using a positive power. Okay, 1, 2, 3, 4, 5. So I use a positive power. You don't have to put the plus there. I'm doing it to kind of show you how. Anyway, mom has a whole bunch of problems asking you to convert from scientific, from standard notation to scientific, and scientific back to standard. There's only one. Okay, let me show you the advantage of it a little bit. By the way, your calculators can actually work in scientific notation. Matter of fact, if you has anybody ever gotten this 2.03 E7? Anything that looks something like that on your calculator? Well, that's your calculator trying to tell you this is bigger than my screen. I can't put that number up. So that's your calculator trying to tell you that's 2.03 times 10 to the 7. Your calculator is trying to give it to you in scientific notation. Okay. Or maybe you'd have your calculator doesn't quite follow our rules. Sometimes the calculator goes 0.17 E negative 9. We would say for us in the class that this would have to be 1.7 because we want the number between 1 and 9.99999. But your calculator would give you something like this, 0.1717 e to negative 9, and this is 0.17 times 10 to the negative 9. Okay, and what's that mean? It means move the decimal point back 9 places. So you come back 1, 2, 3, 4, 5, 6, 7, 8, 9. You put in a whole bunch of stinking zeros here. Okay, and that's the number, whatever that is. And that is scientific notation, and I'm done with it. Did anybody run across any questions in MOM about scientific notation that you want me to cover? Nope. Okay. Then we're going to go into chapter 7. What? That's my dog. He just came up here with one of those nylon bones and dropped it so I can step on it. Those of you who have dogs, you ever give them a nylon bone and they put it right by your bed so you get out of bed in the middle of the night and you're walking and all of a sudden you step on one of those nylon bones that they've been chewing on? It hurts.
It does.
Okay. Yeah. They're all sharp and pointy and you go, oh man, whatever. Thank you. Thank you for your bone. I guess it's a gift. Okay. We're going to start chapter 7. And the main thing in chapter 7 is all about something called factoring. Factoring means to rewrite as multiplication. So when the instructions say factor this, your answer better look like a multiplication problem. It better be a multiplication problem when you're done. Factoring means take something, and when you're done with it, it better be a multiplication problem. There's a reason why we use it. Speaking of that, okay, when we all get together, and teachers, I should say, and we brainstorm, and we go, okay, what do students need? What skills are they lacking to succeed in this class and this class? Okay, there are 2 main ideas. Okay, the first is the big one is they don't do enough homework in a timely fashion. We're talking about students. Maybe you do it at the last instant, but that's not good learning. So that's the first complaint that all instructors have. Students don't do their homework in a timely way. They do it at the last instant, or they don't do it and they don't really learn it. That's number one. The number two thing that all instructors complain about is students don't know how to factor. And yet we go, I spent weeks teaching factoring. Weeks. And yet you go off to the next class. Okay, for us, the next class would be Math 104, trigonometry. And the instructor says, okay, factor this. And you go, we never learned that. It's like, we taught you this. And that's one of the main things that cause people to drop out of trig, is because they never really learned factoring. There's another thing, fractions, which we'll get to in a little bit also. We're going to get some algebra fractions. But okay, good study time, good homework skills, and factoring. Those are going to be important in the future. All right. So, okay, the first type of factoring that we always look for is called something in common. So a real simple idea. Suppose you had 5x plus 10. Okay. Now this, as it's written right now, is an addition problem. Yes, it's partially multiplication, but it's got that big fat addition problem. So what you have to do is you have to be able to see inside, and this is where drugs maybe help. This is 5 times x plus 5 times 2. You don't have to write this at all, but you have to see this. You have to envision this. When we say 5x, it means 5 times x. When we say 10, it is 5 times 2. And we ask, what do they both have in common? This and this share what? Well, they both share a 5. So that's called the factor that they have in common. And we talk about, every instructor in the world says, okay, we pull out the 5. Horse bananas, you divide out the 5. Everybody says you pull it out, and that makes sense to all students. But technically, there's no such thing in math called pull out. Okay? Pull out is a crappy form of birth control, is what it is. Okay? We divide out the 5 and we ask, what's left? X plus 2. And that is your final answer. You've just taken this problem, which was addition, 5x plus 10, and by pulling out what they have in common, pull out what they had in common, okay, you pulled out the 5, what was left behind was the x, the 2, and the plus sign. Okay, now this is a multiplication problem. 5 multiplied by x plus 2. Okay, how do you know you did it right? Because you multiply the 5 back in. 5 times x, 5 times 2. Yeah, it's that. Okay, this is called common. So what if we had 6x squared y plus 9xy squared plus 3x. Okay, let's take a second and see if you guys can do it, how much you guys kind of remember. About 30 seconds. So this is 2 times 3 times x times y. When you see 6x squared, that's what you need to be able to see. Okay, you don't have to write it down, but you got to see all those little pieces inside of that. Plus 9 is 3 times x times y plus 3 times x. Okay, again, you need to be able to look inside each one of these terms and see the things that multiply together to make it up. What makes 6x squared y? All of this mess. What makes 9xy squared? All of this mess. And then you start going through and going, okay, what do they all share? What do common means all share. All of them share. Not some of them, all of them. Well, they all have at least a 3. They all have an x. Okay. Is there anything else that they all have? That's really important. Stress on the word all. I don't think so. So we pull out what they have in common. We say they all had a 3x. Okay, pull that out. And then what's left? Okay, a 2xy plus a 3y to the second, the 3yy. And I pulled everything out and I'm wrong. Now, this time I made the mistake on purpose, guys, because I'm trying to make a point here. Okay. How do you check your work? By multiplying it back in. Is 3x times 2xy 6x squared y? Yeah. Is 3x times 3y squared 9xy squared? Yeah. How do I get the 3x? 3x times nothing is not 3x. Okay, so here's the trick. There is always an implied 1 on every factor or every problem we put up. Excuse me, 99 times out of 100, we don't need the 1. Okay, but every once in a while, you do have to put the 1 there. Why? Well, for at least 2 reasons. One, the first reason why is so that if you check your work by re-multiplying, okay, you'll get back that thing. The second thing is a little bit more mathematical. Remember I said there's no such thing as pull out. What there is divide out. If you took 6x squared y and divided it out by the 3x, what they have in common, you'd get that. Okay, you'd get that. If you took 9xy squared and divided by the 3x they have in common, you'd get that. And if you took the 3x and divided by the 3x that they have in common, anybody divided by itself is 1. You'd get that. So the lazy way of speaking is to say, okay, we just pulled out a 3x. The correct way of speaking is to say we divided out a 3x. And when we divided a 3x out, what's left inside is the answer after division. Okay, that's where the 1 comes from. I don't care. I'm not going to question you on, you know, what's the best way or what's the mathematical way of doing this. I'm going to question you on, did you get this answer? Because this is the answer, and that's it. How you got it doesn't matter to me. If you got it, if you could do it all in your head, great. If you needed to go off with scratch paper to do it, that's great too. Okay. So the first thing in chapter 7.1 that mom is going to talk about, okay, is factor out what they have in common. Factor out, divide out. Okay, does anybody need, I should have put the word example up here. would anybody like a couple more, one more problem, I would say, of what they have in common? Just like-
Yes,
You want one more? Okay. All right.
please.
Sure. I need to erase this first one. Is that okay?
Yeah, it's okay.
Okay. So let's go with this one, 15. No, let's be nice. Okay. 8a to the third b minus 6ab to the third plus 2a to the second b to the second. Okay. So I'll pause while you take a second, and the instructions are factor that. I don't want to do that. Apparently I forgot to. Okay. So a lot of people can just look at this and say, hey, the biggest number that they all have is a 2. They all share a 2. 2 goes into 8, 2 goes into 6, 2 goes into 2. Now, what's the biggest number of A's that they all have? Well, that is 3, but that only has 1. That is 2. So we say they all share 1A. All of them have an A. All of them have a B. So if I divide out 2AB out of here, here, and here, divide out or pull out your choice. Okay. 8 divided out by this would be 4. I had 3 A's. I took out 1A. So I have A to the second. Okay. I took all the B's out. So I don't have any B's yet. Minus, again, start again. 6 divided by 2 is 3. Take out an A. Okay, no more A's. Take out a B, so I have B to the second. Okay, took a 2 out, it's gone. Took an A out, so I have an A, 1A. I have a B, and that's my final answer. Now, I can slow it down and show you much more steps. Okay, many more steps. I can do that. But that's the final answer. You ask, what's the most I can pull out of everybody? But it's got to be of everybody, of all of the terms. So is that okay? Or do you want me to show maybe a little bit more detail how I got that? Okay.
For me,
bef-
it's okay.
For you, it's okay? Good. Okay. I forgot to turn the recording on this particular problem, so I need to go over it one more time so somebody gets it in their notes. They're not watching. Basically, when you factor this, you break it down into all the little parts, but there's always an invisible 1 that's part of every number. And if you happen to factor out all of it, like we said, they all have 3x in common, we pull it all out, it always leaves behind that invisible 1. Okay, now it's not invisible anymore. Now it's there. It's important. It's important because when we check our work by remultiplying, we want to be able to do 3x times what makes 3x. 3x times that 1. So I did a much longer, more detailed discussion on that. And I forgot to record it like a dope. So I wanted to go over that now. Anyway, that's what they have in common. And when we're going to get like 4 or 5 different factoring techniques that you're going to need to be experts on. But the first thing you will always, always try to do is look for what they have in common. We're going to learn all kinds of fancy crud, trinomials and binomials and grouping and all kinds of things. But the first thing you always try to do is look for what they have in common. Okay, always first. That's why I said first. Now I need to erase the board and move on to factoring that's related. Are we okay?
You said factoring is for, used for trig?
I'm sorry.
You said
it-
factoring is used for trig?
What? No. Well, yes and no. Factoring is used in all kinds of places. Our next course is supposed to be trig. If you're in this course, most of you will either go to trig or to college algebra, math 104 or 116. And in both of those, there's an assumption that you know how to factor. Okay, because a lot of their problems are built around factoring. Okay, so I don't know. It's a critical skill. And, you know, it's not just those. You go into calculus and all of a sudden you're doing some problem and the instructor says, well, now this problem is really easier if we just factor this thing. And everybody's going, what? What's factoring? Okay, and then they're lost. So factoring is a skill that's going to be necessary from here on out, not just trig, but really starting in there.
Okay, thank you.
Yeah. Okay, now. I want you guys to look at this 3xy plus 5y versus 3x 2a plus 1 plus 5 times 2a plus 1. Okay. Look at this problem versus this problem. If the instructions were factor, which just about everything for the next several days is going to be factor, factor, factor. From an instructor's point of view, there is absolutely no difference between this problem and this problem. Let me show you what I'm talking about. Okay, it seems strange because you're going, whoa, this has a y, this doesn't have a y, it's got this 2a plus 1. But it's how they work. So let's look at this. What do these two have in common? Well, they have a y. So we can factor the y in front. We can pull it in front. Okay, y. And that leaves 3x plus 5. That's what we just did. What do they have in common? They both had a y. So we pull the y in front and the 3x and the 5 kind of fall back together. Okay, look at this. What do these two have in common? Oh, look, they both have a 2a plus 1. So we can pull the 2a plus 1 out front, just like we pulled the y out front. And what happens? 3x plus 5 kind of fall back together. So in this problem, they had the common monomial. They just had y. Y in common, we pulled it out front. This problem, they had a common binomial. But it doesn't matter. It was they had it in common. So whatever they had in common, no matter how ugly it is, we pull the thing that's common out front. Okay, it doesn't have to be a nice, pretty single letter or single number. It could be a binomial. Oh, heck, you want to see some, you don't, but too bad, some trigonometry? suppose you had 6 sine squared plus 9 sine. Now I know it says sin, but in trigonometry we say sine. There's some other things missing that I'm leaving off because I don't want to confuse you. Sine is a function that we study in trigonometry. It's a function. It's a special weird function. Remember how we studied f of x? And we're going to come back and study them more. Sine is a function. Well, what do they have in common? Okay, well, 3 goes into both of these. Okay, in fact, let's look at this. This is 2 times 3 times sine, because squared, there's 2 of them, plus 3 times sine. Okay, well, what do they have? They both have a 3. They both have a sine. So we pull it out front. They have a 3 and a sine that they pull out front. And what falls together? The 2 and the sine plus a 3. And that's trigonometry. There is no difference, okay, between these 3 problems, mathematically speaking. They all had something in common. We pulled that common math term or math idea out in front, pulled it out, and then whatever was left behind all just got stuffed in the back parenthesis. Okay, so there's a problem right from trigonometry for Math 104. Okay, and you'll be doing that relatively soon in the semester when you get there next year. My point back to here is you don't have to have a single thing that they have in common. It could be a dual, a binomial that they have in common. Okay, what's that got to do with you guys? Well, there is another type of factoring, okay, known as grouping. Now, grouping only kicks in when there are 4 terms. Okay, that's kind of one of the things you're going to get confused with is we're going to have, like I said, 5 or 6 different factoring techniques. And you're going to be pulling your hair out going, what do I do first? What do I do second? Oh my God, what do I do? Okay, well, the first thing you always do is look for what they have in common. That's first. If there are 4 terms, okay, then you do this grouping technique. So I'm going to show you that now. Then we'll go on to another technique in a minute. Okay, so if there are 4 terms. So here we go. A to the third plus 4a to the second plus 3a plus 12. Okay. Now, looking at this, okay, very important question. Do they all have something in common? Is there something that goes into all of these? Okay, A goes into the first numbers, first 3, but not the 12. Okay, no, they don't have anything all in common. That's very important. Common means all of them share something. But it's called grouping. Okay, what grouping means is you put parentheses, look where I put the parentheses. The top line is the original problem. This next line is the new problem with parentheses. I put them around the first group. I group grouping symbols. I group the first two. I group the second two. Okay. A question you need to ask yourself is this problem, this line here, with the parentheses, the same as this one? And the answer is right now, yes. In a little bit, I'll show you the answer would be no, and I'll show you how to fix it. All right. Well, we grouped it. We threw parentheses in. Is there a way I can factor just this first group? What do these have in common? Well, they both have an A. Whoa. They both have bigger than an A. They have a to the second power in common. Okay, so I could say, can you guys see that? If we write a cubed, you got AAA. 4 is AA. So when I look at this, I see this has two A's and this has two A's. So they have a to the second in common. And what falls together? The A plus the 4. That okay with everybody or not? Okay, again, this step right here, you can do it in your head. But you have to be able to see inside of a to the third and notice that it's 3 A's and 4a to the second is 2 A's. So what do they have in common? 2 A's. Okay, now move over here. What do these have in common? Anybody want to take a shot? What do you think they have in common?
3.
A 3, good. They have a 3 in common because this is 3 times A and this is 3 times 4. So they have a 3 in common. So I bring down the plus and I say they had a 3 in common. And what's left behind? An A plus a 4. Now notice, okay, something really cool just happened. I think it is. You guys are going, what the hell is he talking about? Look at this. They both have an A plus 4. It's not factored yet. It's not factored because this is partially factored. This is partially factored. But that big fat plus sign in between says, no, ain't factored. But wait, why can't I pull the A plus 4 in front? Because that's a common binomial that they share rather. I can pull it out front as an A plus 4. So if I pull the A plus 4 in front, what falls together? The A squared and the 3. All right. What can I clarify? This is probably one of the hardest types of factoring, but it's critical to something we're going to be doing in a few minutes. Okay, this is not, people normally don't see this. It's called grouping because you just throw parentheses around the first two and the last two. The plus sign stays, separates them. It's not inside of a group. First group plus second group. Okay, and then you factor each group independently. You say, well, what can I do here? What can I do here? And if life is good, if the math gods are smiling, they should always have the same binomial in common. Binomial means two terms. If they do, you can continue and pull it out front like I did here. Questions? Okay. I'm going to give you more problems, more practice problems. Okay. But I do need to point out, guys, if I write XY, or let's say I write 3 times 5. Okay. What if somebody else wrote YX or 5 times 3? Who's right? Who's wrong? Does it matter? Is anybody alive out there? Has my thing frozen? No, I'm not frozen. The point is, for multiplication, it doesn't matter how you write X times Y or Y times X. Or you go 3 times 5 or 5 times 3. You get 15. So I have this, but okay, sometimes the books will write this: a squared plus 3 times a plus 4. Both of those are the same. Both of those are 100% credit. Okay. I like the a plus 4 in front because we always talk about pulling what they have in common out front. Okay. Is that all right with everybody or not? The order that you put those two terms doesn't matter. As long as one of them is an a plus 4, one of them is an a squared plus 3, and you got parentheses around both groups, I'm happy. Okay, let's try this one. You guys try this one. Okay, no tricks yet. This is pretty straightforward, I think. I hope it is. Yeah. So 3x to the third minus 3x. Make that 3x to the second minus 3x plus 2x minus 2. Take a second. It should more or less follow what I did here. Okay. So the way I started it was I rewrote the problem and I threw parentheses around the first two and the last two, leaving the plus symbol kind of separating the two. That's important there. Then I asked the question, is this problem with parentheses equivalent to the original problem? Did the parentheses change the problem in any way? And right now, the answer to that is no. In a few minutes, the answer will be yes. So then I look at the first group and I go, what do they all have in common? What can I factor out in common? Okay. And so I'm going to jump to the answer and then you guys are going to yell and scream at me. This is 3x times x minus 1.
X.
I'm sorry. Go ahead. Somebody started to say something. Okay. Remember when you take all of something out, the 3x, when you take the whole 3x out, you have to leave that placeholder 1 because you need to be able to check your work. Okay. Plus, here we can take out a 2, factor out a 2, or divide out a 2, as you will, it doesn't matter, but it's the point is it still leaves x minus 1. Again, check your work. 2 times x is 2x, 2 times minus 1 is minus 2. Okay, 3 times x is 3x squared. 3 times minus 1 is minus 3x. So you just keep checking your work. But I'm not done because I look here and I go, whoa, look, they have a binomial in common. They still have something in common. So I can pull that common term out front. I pull the x minus 1 out front. Who falls together? The 3x and the 2. And that's your answer. So that's it. And it doesn't matter whether you had 3x plus 2 in front and x minus 1 in back. As long as you've got those two quantities, you did it right. Are we doing okay?
Yes.
Okay. Anybody, any hesitation? Because I'm going to try and trick you on this next one a little bit. Did you guys all understand where the magic 1 or why it showed up? It's you're dividing out of 3x. 3x divided by 3x leaves the 1. That's what you're doing there. Any questions? All right. Okay, we'll do this one. And then we'll move on. Okay. Be careful. I'm trying to trick you a little bit. 12x squared plus 18x minus 10x minus 15. 12x squared plus 18x minus 10x minus 15. Okay. We're pausing this. Or you got messed up. So let's start again. 12x squared plus 18x minus 10x minus 15. Throw parentheses around the first two. Leave the minus sign. Throw parentheses around the second two. And the question I asked was, is this new problem with the parentheses equivalent to the original? And this time the answer is no. By putting the parentheses in, I've changed the value of the problem. Okay, I've changed it. I can't do that. All right, the question then is, what changed? Looks the same to me. But with these parentheses and this minus sign here, remember you distribute a minus sign. So minus 10x, well, that's minus 10x. But minus a minus 15 is a plus 15. But originally it was a minus 15. So this minus sign changed the 15 to a plus 15 instead of the original minus 15. You can't do that. You just can't do that. You can't change the original problem. So what we do is we cheat. And I don't know how you're going to get this in your notes. You can write cheat all you want. Okay. But we turn this minus into a plus. We just change it. Why? Because if we said minus a positive 15, it's now what it was supposed to be originally. It's now a minus 15. Minus a plus is a minus. So you just make this one little tweak to the problem so that now this problem with parentheses is equivalent to, is worth the same as the original problem. Okay, that's super important. Hint, the only time you're gonna have this problem is if there's a minus sign in between right here. That's when life is gonna get a little ugly. That's when you have to remember this little cheat step. Okay, so here we go.
Question.
Yes,
Can't you just put plus and make both those negative?
yeah, and then what would you do? Yes, I can see that, but I don't know, what would you go from there? What you want to write this is plus negative 10x minus 15, and then what would you do?
I mean, you would just put 5.
No. It's a minus 5. Since they're both negative, you factor out a minus 5. See, that's a negative, that's a negative. You're right about the 5, but you factored out a negative 5 there. Okay, because they were both negative. You can do what you said, but you've got to be real careful about saying, oh, they're both negative, so I can pull a negative out of everybody.
Yeah, but wouldn't you like for the, when you group it, it'd be 5 parentheses minus 2x minus 3?
Okay, hang on. Let me show you why that won't work. Let me do this problem out. Okay. So here they have a 6 and an x. 6 goes into 12, 6 goes into 18. X and x. So this becomes 2x. 6 goes into 12, 2x plus 3 minus. Okay. What do these two have in common? 5, my way. Hang on, I'll show you your way in a minute. 5. And if I divide out of 5, I have a 2x plus 3. Notice, remember my big check here. Every time I did this problem, I said this quantity and this quantity have to be the same. If they're not the same, we've screwed up. Because since they're the same, we can factor them out front. Okay, and have the 2x plus 3. We can pull it out front, and what falls together? The 6x and the minus 5. Okay, now let me do it your way.
Okay, I get it. I see why you did that.
Because your inside quantity wouldn't be the same as this one.
Yeah, I got it.
You can fix it by factoring out a negative 5. That would reverse the signs and you would be okay.
Thank you.
Yeah, you're not wrong, but it's leading you to the possibility of a wrong answer. And I'm trying to cut that off right now. Okay, other questions? That's grouping. That's grouping. By itself, I don't feel grouping is very important. There's a few homework problems on grouping in Mom. Maybe one question on the quiz or the test on grouping, 4 terms. By itself, grouping is not important, but grouping is critically important for the next kind of factoring that we want to do. Okay. Okay, you should still all be awake right now because this next thing is the hardest type of factoring that we have. Okay, do you guys want to take about a 2 or 3 minute break, stand up and stretch before we get into the
Yes.
hard part? Okay, all right, let's take a 2 or 3 minute, let's pause 2 or 3 minutes, stand up and stretch, go get some coffee because this next stuff is tough. Okay, so we're back to the kind of factoring, it's called trinomial factoring, that really seems to give students the biggest problem. Okay. We need some vocabulary. For a trinomial, we learned in chapter, was it 5? 6, I guess it was. Trinomial means 3 terms. Well, here's a trinomial, okay? A is always considered the coefficient of x squared. B is always considered the coefficient of x. C is called the constant. Okay. A is coefficient of x squared. B is the coefficient of x. C is called the constant. It has no variable. Now, I should point out that a trinomial could have minus signs in it also. Okay, that we just say plus because it's easier, but it could be minus also. We're just lazy. Ax squared plus bx plus c. The coefficients, the a, b, and c, very important. A always goes with the x squared, b always goes with a single x, and c is always the constant. So an example might look like this. 3x squared minus 2x plus 5, something like that. Okay, so that would be a trinomial. The a value is considered to be 3. The b value is a -2 or a -2. The c value is a 5. Okay. Again, we could have -4x squared plus 3x minus 7. Okay. -4 is the A, +3 is the B, -7 is the C. That's the A, B, and C. That's going to become important because I'm going to give you what's called an algorithm. An algorithm is a rule that you follow that gets you to the answer. Okay, you don't have to understand the rule, you just have to be able to use the rule. It's called an algorithm. Okay, we used to make jokes about vice presidents dancing, but we can't do that. That's not politically correct, and nobody remembers who Al Gore is anyway. Okay, so we have a trinomial. Now, we're going to use what's called the AC method. AC plus grouping. That's the technique we're going to use. Some of you have learned this as a cross. Some of you have learned this as a diamond. Okay. There's all kinds of different names for what we're going to do. There's also a really fast way of doing this. This way is slow but sure, which I'm going to teach you in a minute. Slow but sure. Okay. There's a much faster way, and books call it guess and check. If you're good at multiplication and addition, subtraction with positive negatives, then the guess and check method will get you the answer in about half the time, usually. Okay, but this way will always work. AC plus grouping. That's what we're going to be using. If my discussion here, okay, kind of helps you to remember something that you've learned in the past, and all of a sudden it kicks in and you go, oh yeah, I remember it, and I can do it this way, as long as you get the same answer I get, it doesn't matter. I don't care. If you remember a different way and you're happy with that way and you get the same answer I get, okay, great. But the key is you got to get the same answer I got. All right, so let's start with a problem and walk through it. Okay. Let's start with this example. 6x squared minus 5x minus 4. Okay. So we want to come off to the side and we want AC to be 6 times -4, which is -24. AC, 6 times -4. 6 times -4, -24. Okay, I'm running out of room here, but now you quickly run through your multiplication tables. What times what makes -24? Well, it could be -1 times 24, or it could be 1 times -24. It could be -2 times 12, or it could be 2 times -12. You just keep running through your multiplication tables. It could be -3 times 8, or it could be 3 times -8. Or it could be -4 times 6, or it could be 4 times -6. Okay. So AC was -24. You quickly run through all of your basic multiplication tables. What times what made 24? But here's the key. You also want them to add or subtract to make -5, the B value. They have to multiply to make -24 and add or subtract to make -5. So out of all that junk I listed up there, there's only one that works. Which one is that?
-3 times 8, or the other one?
3 times -8.
Yeah, remember it's got to make -5. -3 times 8 makes +5. 3 times -8 makes -5. That's the one we want to use. 3 times -8. It's not just makes 5, it makes -5. Okay, so this was a lot of wasted work. If you, when you're doing your homework and mom, you go, well, wait, there's no way 1 and 24 is going to make add or subtract to make 5. I don't have to waste my time on that. Okay, there's no way. Probably 2 and 12. No way 2 and 12 add or subtract to make 5. Whether they're positive or negative. So you can save yourself a whole lot of work. I'm just showing you what you had with the thinking process. What multiplies to make -24 and simultaneously adds or subtracts to make -5. And the only one we have here is 3 times -8. All right, watch carefully. The hand is quicker than the eye. We're going to take that 3 times -8, and we're going to go 6x squared plus 3x minus 8x minus 4. Before I go on, it's important that you understand that that's -5, that's -5. I haven't changed the problem. I've changed what it looks like, but not what it's worth. The B value was -5x or -5. It still is -5, just in a different format. But now notice it has 4 terms. I've taken this and exploded it into these two. Okay, and now I have 4 terms. Now I can use the grouping technique, AC plus grouping. Okay, I'll go through this quickly, and it's a good thing we talked about that problem earlier. Okay, I'm going to write this down a second time because I'm going to put the parentheses in, and I'm going to ask the question by putting the parentheses around the first group and around the last group. Is my new problem with parentheses equivalent to my problem up here without parentheses? And the answer is no. that 4 inside the parentheses needs to be cheated. Because remember, it's going to get hit with this negative. So if we turn that into a plus 4, okay, now this is the same as this step. Okay, because the minus will change the plus 4 back into a minus up here. All right, factor out what they have in common. These two have a 3 and an x. So if I divide it, I get 2x plus 1. There's that old 1 again. Remember, when you factor the whole thing out, it leaves behind a 1 minus, okay, what do these two have in common? Well, they have a 4. 4 goes into both of them. If I factor out a 4, it leaves behind a 2x plus 1 again. Okay, and look again, we go, yay, look at those. They're the same. So I can factor them out front, pull them out front, and I have 2x plus 1. The parentheses are important, guys. The group 2x plus 1 pulls out front. What falls together? 3x minus 4. Again, remember, it doesn't matter really who comes in front. If you want to put the 3x minus 4 in front and the 2x plus 1, even mom doesn't get nitpicky over that one. But this is your final answer. Questions? You sure? Because usually people are just kind of like dying right about now. They're going, oh, wait, no, hold it, stop. You're sure? Either that or you're so lost that you don't even know how to ask a question. All right, well, let's try another one. Okay, it was called AC plus grouping. First, you calculate the AC, whatever A times C was. Then you start going through your multiplication tables. What times what makes 24 or the AC. And at the same time, adds, subtracts to make the middle term, the B. Take those two numbers, okay, replace the middle term with those two numbers, and now you're doing a grouping problem. Okay, let's give me one. Well, shoot, I don't like that. It's too big. Too big in numbers. I don't like that at all. That's the same problem. Come on, idiot. Okay, that'll work. The reason I'm working this is because all my examples were pretty ugly. 6x squared plus 13x plus 6. So I want you to factor that. So our AC is going to be 6 times 6, which is 36. 6 times 6 is 36. But now we start reading through our multiplication tables very quickly. What times what makes 36, but adds or subtracts to make 13? Okay. Okay, so we already know 6 times 6, but it could be, well, it's going to be 4 times 9 is 36, but -4 times -9 is also 36. You need to be careful about that. Okay, 4 times 9 is 36, positive, positive. -4, -9 is -36. But wait, we want them to add to a positive 13. That's what that says. So which ones are we going to use? Anyone?
4 times 9.
Yeah, you're going to use those. So real quick, and guys, there's a lot of issues. People don't know, okay, do I put the 4 first or the 9 first? In the end, it doesn't matter. It doesn't matter. I just put them the way I write them. So I have 6x squared plus 4x plus 9x plus 6. Okay. But if you wanted to reverse the 4x and the 9x, your steps will look different than mine, but we'll get the same answer. So don't panic on that. Okay. So here I go, double write it. Okay, because I'm going to throw some parentheses down. First group, last group. Okay. Did my parentheses change any values in the problem? No, because that's a plus sign. The only time you're going to run into that screwy thing about, oh, it changed it and I have to use Foster's cheat step, is if that was a minus sign. That's the only time things are going to get screwy, if that's a minus sign here. Otherwise, you're safe. So here I can take a 2 and an x out. Divide it out. That leaves a 3 and an x plus a 2. Double check your work. You could always double check. It's 2x times 3x, 6x squared. Yeah. It's 2x times 2, 4x. Yeah. Plus, here I can take a 3 out. 3 goes into 6 and 9. Take it out. I have a 3x plus 2. Your built-in check is this quantity and this quantity. They have to be exactly the same. If they're not, you screwed up somewhere. They have to be the same. That's how you know you're doing it right. If that quantity and that quantity are the same. So factor that out, take the 3x plus 2 out, factor it out. Who falls together? The 2x plus the 3. And that's it. And again, like I keep saying and said several times, you can put the 2x plus 3 first. It doesn't matter. And the 3x plus 2. Are we kind of okay? All right. I want to show you one more thing. Then I want to go to Canvas for a second and then call it a night. So hang with me for just a little bit. I'm not sure why mom does this in 7.2. That's what we're in now. This kind of all morphed. And this is, I'm sorry, I should have said this. This is chapter 7.2. Actually, and it's also 7.3, kind of, sort of. Okay. I'm not sure why mom puts it in here now, but there was no way I could get rid of it and move it to a different, to later in the lesson. So I need to show it to you tonight. Okay, so can I erase this here?
Yes,
No, it, yes, was that a yes?
yes.
Okay, all right. So suppose we had this problem. Now, this is a trick problem. Again, I think for some people, it's too early. Whoops, that's not the one I want. Come on, idiot. It's too early to teach this, but I'll review it again. 5x squared plus 21xy plus 4y squared. Okay. How is this problem different from the previous trinomials? Or from this trinomial right here? Anyone?
Three different variables.
Yeah, there's two variables there. There's an x and a y. All right. For what it's worth, the way I like to do it is to ignore the second variable. Just ignore it. In other words, think of this as 5x squared plus 21x plus 4. Just dump the y, the extra y. So let's take about 2 or 3 minutes for you guys to then do this problem, and I'll show you how to adjust it at the end. Take a couple minutes, use your AC plus grouping to do this problem where we've ignored the second variable. Just ignore it. All right, so here we go. The original trinomial had two variables, x's and y's. We're ignoring the second variable, the y. Okay, so we're doing this problem. In this problem, 5 times 4 is 20. That's my AC. But what times what makes 20 and adds to 21? What times what multiplies to 20 and adds to 21? Well, to me, 1 times 20 or 20 times 1, it doesn't matter. 1 times 20 or 20 times 1. So we come over here and we take this as, we write this as 5x squared plus 1x plus 20x plus 4. Again, all we're doing is taking 21 and finding a different way to write it. That's all we're doing. It's still 21. We're just kind of manipulating it a little bit, making it look different. All right. Same thing, 5x squared plus 1x plus 20x plus 4. Throw some parentheses around, everybody. Boom, 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 boom. No change. This is the same as this. So here I can take out an x, leaving 5x plus 1 in this group. Take out an x, 5x plus 1. In this group, I can factor out a 4. 4 goes into 20, 4 goes into 4. Remember, you're dividing it out. So 20 divided by 4 is 5x. 4 divided by 4 is 1. Okay. My check is that quantity and that quantity the same? I think I have room here on the board. Yes, it is. So almost final answer is that. Bring the 5x plus 1 out front, 5x plus 1, the x plus 4 kind of fall together into a group, and you're almost done, almost done. Okay, but this particular problem had two variables, and we ignored the y. So now all you do is stick it back in. Question is where? Well, the y squared was in the back end. If you put a y here and a y here, if you just go back and sneak it in, look at what 1y times 4y is 4y to the second. So if you cheat a little y there at the back of the first binomial, and you cheat a little y at the back of the second binomial, you'll have created 4y squared, and it's done. That's the correct answer. You can multiply it together if you wish, but that's going to be the answer. So what did I do? Ignore the second variable. Okay. Do the problem as if there was one variable, AC plus grouping, but at the very last step, sneak in the missing y. And you always put it at the back end because that's where y was. Y squared was at the back end of your trinomial. Okay. Let's hope. So far, my screen isn't blown up. I've been writing the Zoom people or talking to them. So let's go here. Okay. Can everyone see my Canvas page? I forgot to ask that.
Yes.
You can all see that because I'm never, I don't trust whatever in the hell this thing is doing. All right, in modules. Okay. First off, in Lisi's module, these are the worksheet and the keys that she's been doing the last couple Mondays. So if you missed her practice session or whatever, there's the worksheet, and then there's the worksheet with the answers that she did in her tutorial. But what I want to show you guys down here is exam number 1. Okay, actually, I want to go into student view. Wow. Okay, there we go. Student view. Okay, exam number 1. Okay, 2 things here. First off, this breakdown of topics tells you, actually, let's look at it. Come on. Anytime this century. Ah, there we go. So I've given you here, you could read this on your own. I'm just going over it rather quickly. Okay. You will do it on your own paper. I'll give you the problems all squished together. You'll use your own paper and a scientific calculator, but you can read this in more detail later. But I'm telling you, in chapter 1, there will be 2 problems. They will be like this. In chapter 2, there will be 3 equations, 1 inequality, 1 absolute value problem. Okay, I'm giving you the breakdown. I'm not giving you sample problems. You have mom, you have all the notes that we have. In chapter 4, write the equation of a line. Okay, we've done that all over the place. Chapter 5, 2x2 systems, 3x3 systems. So everything that's going to be on the exam is here, including there's going to be a few multiple choice problems. Okay, but I want to go back. How come it won't let me? Oh, I know why. Okay. Go back to modules. And let's go down to exam again. Here, and I'm not going to bother opening it up because it takes too darn long. I have a practice multiple choice test. It's practice. The answers are attached, but you can see, oops, I made a mistake. The answers to number 1 and 29, they're just wrong. Yell at me in class over the next couple of days or before the final. You don't have to do this. This is optional. I should have written that in there. In fact, I may change it. This is practice. You do not have to do it at all, but it would be good practice. Okay. If you want sample problems, here they are. But these are multiple choice. The vast number of problems on exam 1 are going to be showing your steps, just like everything I've been doing on the Zoom board back here. So tomorrow night, I'm going to continue with chapter 7. Not sure how far we're going to get, but we're going to continue with chapter 7 tomorrow night. You can ask questions from any place you want. We have to get through chapter 7, well, before the final or the exam number 1. So with that, I'm done. So good night. See you guys all tomorrow night. Please, you have chapter 6 and now 7 homework that you can be working on.
Hey, Professor, how we got taking roll today?
Nope, I'm not going to do it today.
All right. Thank you. Have a good night.
Okay, you too.